Physical properties of rubber. Okay, now this is related to the vulcanized rubber. We want to compare a natural rubbers and a vulcanized rubber. So before we discuss vulcanized rubbers, we need to know the physical properties of natural rubber. Natural rubber is elastic, okay, elastic, and then it can be oxidized by oxygen and ozone. It can be oxidized easily. Effects of solvents: it does not react with water, acid, and alkali, soluble in some organic solvents such as benzene, and it does not resist to heat, and at high temperature it becomes soft and sticky. So this is the physical properties of rubber, and you need to remember this. Okay. Why this natural rubber is soft and less elastic? Okay, why? That is because the forces of attraction between the rubber molecules are weak. Okay, what does this mean? Just now we learned that rubber is a polymer. Okay, so this is a polymer. Let's say it's a very long chain. So this is another one which is a very long chain. But then in between this molecule and this molecule, there is no chemical bond. There is just a weak force between this molecule and this molecule. So the forces of attractions between the rubber molecules are weak. For this molecule and this molecule, the forces between them are weak. And if you stretch this rubber, so if you stretch rubber, these molecules can easily slide over each other. You pull this, it will go to the right hand side. Okay, you pull this to the left, it will go to the left hand side. So one molecule can slide over on another one easily. So this makes it soft and less elastic. So if the rubber is overstretched, the rubber molecules can no longer return to its original position. So if you stretch it too much, then it cannot return to its original size, shape. Then we say it loses its elasticity. The rubber will lose its elasticity. So as a result, the rubber loses its elasticity. So to strengthen the rubbers, we use vulcanizations. Okay, the process called vulcanizations. Natural rubbers is vulcanized to improve its characteristics so that its usage could be wider. What does this mean? Vulcanized rubber is a rubber that has been heated with sulfur. So we heat rubber with sulfur. Okay, we heat rubber with sulfur. This is to vulcanize it. Vulcanized rubber is prepared in laboratory by soaking the rubber in the solutions of disulfur dichlorides or sulfur monochloride or methylbenzene. We put these rubbers into this liquid, disulfur dichloride or sulfur monochloride. So when you add sulfur into the rubber, okay, so this is a rubber molecule, right? It's a rubber molecule. So if you add sulfur into the molecule, now inside this molecule there's still double bond. There's still double bond. So the sulfur will be added into the double bond. You add sulfur, the sulfur will be added into the double bond, and it will form this KSSC cross link, carbon sulfur sulfur carbon. KSSC, carbon sulfur sulfur carbon. So you add sulfur, then it will form a cross link. Okay, this carbon and this carbon, it will form a bond. So it has this KSSC cross link. Now initially for natural rubbers, this rubber they can slide over each other's, right, when you stretch it. But after you add the sulfur, this sulfur form a bond between these molecules, and now it's very hard for us to break this bond. So then this is called vulcanized rubber. So that's the difference between natural rubbers and vulcanized rubber. The vulcanized rubber, we add sulfur, and the sulfur form this KSS cross link between the rubber molecule, and this make it become more elastic and stronger. Okay, in exam they may ask you to draw the structures of the vulcanized rubber, so make sure that you know how to draw it. So the differences between natural rubbers and vulcanized rubbers. Natural rubber, they are soft, less elastic, non-heat resistant, low melting point, and easily oxidized. But after it's vulcanized, it become hard, more elastic, more heat resistant, high melting point, and it can resist oxidation. Means it's it become very, very useful. And make sure that you remember this. Okay, the differences between natural rubbers and vulcanized rubber. And the last one, with the help of a diagram, explain why vulcanized rubber is harder and more elastic than the natural rubber. So you draw this. If they ask you to explain, you draw the natural rubber, just one chain, again with some double bond. And the vulcanized rubber, there's the CSS cross link. So in exam, you just draw this, is okay already. Yeah? So after you draw these two diagrams, then you explain. In natural rubber, there is no chemical bond between the rubber molecules, therefore the forces of attraction between the rubber molecules are weak. And in vulcanized rubber, there is sulfur cross-link between the molecule, and the sulfur cross-links prevents the polymer chains from slipping past one another when it is stretched. And as a result, the vulcanized rubber is harder and more elastic. So this is the explanation.